Hello. Today I want to uh, explain how you can apply multiple linear regression with your data. Now we have one output and four inputs, or in other words, we have four independent variables and one dependent variables. Our output is the evapotranspiration, and you see, as you see, we have four different variables: air temperature, wind speed, solar radiation, and relativity. So we want to apply linear regression between these variables and evapotranspiration. So we will use now data, and we will use data analysis toolbox. Under this toolbox, we have a regression option here. We tick this and then tick OK. And then we assign input Y range by considering the label. Here we selected. And then OK, and X range, uh, which variables are our inputs, and also considering the labels here. And then you see this is the last column, and this is the second, third, fourth, and fifth columns. So these are the inputs, and this is output. And labels, so we involved labels because, and you can also set constant is zero. Means there is no bias. If you don't want bias in your regression, you can tick this. However, we want to add bias also because it's more flexible when you use bias in your regression equation. So confidence level generally is set to 95%, and output range we will change. So you can also calculate in another worksheet. But in this in our example, we prefer output range. We will show some cell to calculate that. And we want to show also residuals, and line fit plots. And so we also we want to see this. Then we will show a cell where we want to paste the results. So here we can paste this cell. Then we will tick OK. And now it will calculate the regression coefficients, and also it plots here. You see the relationship between evapotranspiration and each variable. You can see there is a relation between inverse relationship between relative humidity and evapotranspiration. So you can see each relationship between each variable and output or evapotranspiration. So here you see the ANOVA test results with this data, and here is very important for us. Interception, this is bias volume, intercept coefficient here, and you see this is each constant parameter multiplied with each variable or corresponding each variable. And here also standard errors are given, calculated, and t-values are calculated here, and here lower and upper percentages and quartiles. So here t statistics shows the importance of each parameter. So you see solar radiation is very effective on output, and second wind speed or not air temperature, and others separately effective on evapotranspiration. So how we can calculate our regression by using these coefficients, I will show now. And here we can write here multiple linear regression now, and then we will calculate our multiple linear regression results here. So we will write equation, and we will first add intercept intercept, and we will should keep this constant. So how we can do this? We will add here dollar sign. So this means this will be a constant every time. because this will not change when we shift this cell to the below or downstream downs to calculate for other values. So here intercept we wrote here, we located here, and then plus, and this coefficient multiplied by the corresponding the air temperature data here. However, we should also set constant this by adding dollar, and then plus wind speed coefficients. Again, we will set dollar here, and then we add plus and solar radiation, and here we should add multiply by the wind speed, and this is the coefficients for solar radiation, and multiply by solar radiation, and plus relative humidity, our last variable. This is constant for the relative humidity. Again, we set it as a constant and multiply by multiplying with the relative humidity data, and then we will tick here, and this is our results for the first set of data. So when we shift this cell to below, and then it will directly calculate, and you can double tick here, and you double tick, and this automatically calculates all the data for all the data. So you got the linear regression here. And then we can check the results with the observed values. This is observed or measured values, and this is multiple linear regression. And then together we can select this together like this, and then we can draw, we can insert, and we can select here, and for example, select this is a scatter plot. And now we can see there is a scatter plot, and it shows the multiple linear regression results with the also we can carry here, and this is linear regression between the observed values and the observed values and the regression results. So we can add here, labels, Excel titles here, and we can set it here and as yeah, access properties. Here we can select the range. So this is access title. We can write the title here. Which title? This is multiple linear regression or ET calculated by multiple linear regression. And here we can write the evapotranspiration or observed evapotranspiration. We can write like this, and then here we can change the access options, access range. Here access options, and this we can remove the zero values. We can set it as 0 now. And here also we can do this also similarly. From access options we can set as 0, and then yeah, now you can see the linear relationship. And I want to, so we can remove this part, and now we can add the linear regression here, add trend line. Here we can add trend line, and also display equation, fit line equation, and R square value. So you can see now the fit line equation and the R square value for our linear regression. By this way, you can also divide data into two, training and testing. And the first part, with the training data, you can obtain the coefficients. And in the second part, you can use the same coefficients with the testing data or the separated data. Thank you for your patience.